Hello, we are back with a new lesson, and to start we have this puzzle, this math puzzle, and I know it's not Christmas anymore, but there's something special about this Christmas tree. It's kind of a math Christmas tree. Have a look. The Christmas tree at Pascal's house was decorated with special ornaments. One from the bottom fell down, the one here on the question mark, and broke into pieces. What was the number on it? Try to think, try to imagine how to find the number. Try to make sense of this arrangement, the order of the numbers, and think if you can find out the number that is missing. Okay, this is the math puzzle for today, and we will work on chapter 3, graphs and functions, starting with section 3.1, graphing equations. The first objective is to plot ordered pairs, and let's just check a few definitions. Ordered pair are two numbers associated with a point on a graph. The first number is the horizontal location, and the second number is the vertical location. Coordinates, a number in an ordered pair that means x coordinate is the first one and y coordinate is the second one. X-axis is the horizontal number line, y-axis the vertical number line. Origin, the point of intersection of the x-axis and y-axis. And quadrants, the four regions divided or created by the intersection of the two axes. To graph an order, a point corresponding to a particular order pair, you must start by the origin, then you move x units to the left or to the right, depending if the number is negative or positive, and then you move y units up or down, depending if the number is positive or negative. Okay, we will practice. Let's work now on a few examples to understand how to graph ordered pairs. Okay, so let's say we have, first thing, we have to identify the order pair 0 and 0. This is the origin. How can I find out 0 and 0? Right this point, which is the origin of the xy axis. And another example, let's say we have 5 and 3. This order pair 5 and 3. We start here from the origin, 0, 0, and we will move. First number in the order pair is the x coordinate. That means we will move 5 units to the right, starting here from 0, 0. 1, 2, 3, 4, 5. Right? And now we move, this is the y coordinate, the second number or the pair. We're going to move 3 units up. 1, 2, 3, here. So this is 3. And the point with the order pair 5 and 3 is this one right here. Another example, let's say we have the point 0 and 5. How can we find point 0 and 5? Let me clear this up. And 0, as you remember, is the origin, right? So right here you're going to have 0, 0. This point, which is the origin. For x equals 0 is going to be on the same position of the y-axis, where x equals 0, and 5, we don't move right, we don't move left, we stay here, and then 5 up, 5 units up. 1, 2, 3, 4, 5 points we are looking for. 0 and 5, and it's going to be right here. Another point, another example, -4 and 2. So x is -4, we will start from the origin and move 4 units to the left. So 1, 2, 3, 4, -4. Y equals 2, we will move 2 units up, 1, 2. The point, the order pair, -4 and 2 is represented by this point right here, -4 and 2. Okay, I think I erased 5, 3, 1, 2, 3, 5, 1, 2, 3. This is 5, 3. And more examples, let's say -6 and 0. -6 and 0. From the origin, we're going to move -6 units is 6 units to the left. 1, 2, 3, 4, 5, 6. Let's move. And 0 to up. We're not going to move up and down because y equals 0. So -6 and 0 is going to be right here. Another point, let's find 2 and -4. 2 and -4. From the origin we move 2 to the right, and -4 means 1, 2, 3, 4 to down. The point to -4 is this one here, to -4. Let's clean everything. Okay, now we have a few points. We can understand how to graph those order pair in the rectangular coordinate system. And another thing that you need to know about the rectangular coordinate system is that it's divided into quadrants. This is the quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? And another thing that you have to notice is the order of the numbers of the coordinate into the order pair is important. It matters. That means check this one. This is -4, 2, right? And compare with this other one here, 2, -4. They are the same numbers, but with a different order. That means different points, different positions. And helpful hint, don't forget that each order pair corresponds to exactly one point in the plane, and that each point in the plane corresponds to exactly one order pair. We're not going to have the same number, the same order pair connected or linked to 2 different points. No, this is not happening. More examples here to really understand and to practice and to know how to graph these order pairs. Let's try here letter A. Now we have the order pair 4, 2. That means x equals 4 and y equals 2. On the x-axis, you're going to move 4 units to the right, so 1, 2, 3, 4. And on the y-axis, you're going to move 2 units up, 1, 2. The point that we're looking for is right here. This is 4 and 2. Okay? Another one, letter B. And we use different colors. Let's say red for letter B, -3, -2. You start here on the origin, on the 0, 0, and move 3 units to the left because it's a -3, right? So 1, 2, 3, -3, and the y is going to be equal to -2. Move 2 units to down, 1, 2. The point that we're looking for, the order pair, is this one here, -3. Oops, negative. Hold on, let me fix this. -3, -2. Another one, letter C. And work a different color. Letter C, 2, x equals 2, y equals -3. So let's find here from the coordinates, the origin, we will move 2 to the right, 1, 2. And -3, that means 3 down, 3 units down, 1, 2, 3. The point that we're looking for is here, this point here. 2 and -3. Letter D, 0 and 4. Excuse me. Letter D, let's use a different color, purple. Purple, 0 and 4. Start here on 0. Well, x equals 0, we don't need to move. We keep in the same position on the x-axis. And now try to find y equals 4. And this is going to be 1, 2, 3, 4, up. Here it is, 0 and 4. Finally, we will work here a letter E, 5, x equals 5, y equals 0. X equals 5, so go to the x-axis, 5, right here. And y equals 0, that means you don't need to go up or down. You stay where you are. And here it is the point. Oops. X equals 5, y equals 0. Let me just clean a little bit and see if we have all the points that we are working. Yeah, we have everything here, only this one. 4 and 2 is here. Right, now we have all the points that we're looking for. Those points here, the order pairs 4 and 2, and the order pair 0 and 4, they are on the first quadrant, or quadrant 1. You don't have anything on quadrant 2, and then we will have another point here. Actually, we have this is in the middle, right in the border between quadrant 1 and quadrant 2. The order pair x equals 0, y equals 4 is in the middle. And we have here this order pair -3 and -2 on quadrant 3. And these two order pairs here, x equals 5, y equals 0, and x equals 2, y equals -3 on quadrant 4. And let me just fix this. Okay. Okay. Moving on, let's work on the next objective to determine whether an order pair is a solution for an equation. Example, determine whether the order pair x equals 3, y equals -2 is a solution of the equation 2x plus 5y equals -4. What you have to do is just to plug in x equals 3, and y equals -2 into the equation. 2x plus 5y equals -4, and check if it produces a true statement, if this is going to be a true statement. So let's do it right now. 2 times 3, so x equals 3, 2 times 3, plus 5 times, and y equals -2, needs to be equals -4. Let's check if this is true, if it's equal -4. 2 times 3, 6. Positive 5 times 2, -10, equals -4. 6 minus 10, -4, equals what? -4? Yes, that's true. That's a true statement. That means, yes, the order pair is a solution. This is a solution for the given equation. Yes, it is a solution. Okay, and let's try another example here. Is the same thing. We have to determine if the order pair -1, x equals -1, and y equals 6, if it is a solution of 3x minus y equals 5. So, plug in x equals -1 and y equals 6 into 3x minus y equals 5. Right? So we're going to plug in and check what happens, if it's true or if it is false. 3 times x equals what? -1 minus y is 6 equals 5. We don't know, let's check. 3 times -1, -3. -3 minus 6 equals 5. What do you think? -9 equals 5. This sounds wrong, right? -9 is not equals 5. This is false. That means it is not solution. Right? And moving to the next objective, objective number 3, graphing linear equations. The linear equation is going to be in the form ax plus by equals c. This is the form of the linear equation where a, b, and c are real numbers, a and b not 0, and this form is called the standard form. First example that we have here, graph this linear equation. Y equals 3 over 4x plus 3. And what we're going to do first is to find a few values for x, and we're going to assume values for x and find the result for y, right? One suggestion, the first suggestion that I give you is to try to avoid working with fractions. And just a general suggestion, and for instance, the one thing that you can guess, one number that you can guess for x to begin with is x equals 0. So if we make x equals 0, y is going to be equal to 3 over 4 times 0 plus 3, right? And this is y equals 3. Another number that we can guess, that we can assume for x, and we're going to avoid the fraction, is going to be x equals 4. Again, you can use any number. It's just a way of making your job easier. Okay, so you can find any number, you can use any number. 4, then y equals 3 over 4 times 4 plus 3. 4 over 4. We can simplify, right? So y equals 6. Another number. Well, we can also use negative numbers if you wish. We can use negative 4, and we also will simplify the fraction with this negative 4. 3 over 4 times negative 4 plus 3. And then we're going to have negative 4 divided by 4, negative 1, times 3, negative 1, negative 3, negative 3 plus 3, 0. You can find a line, you can find the representation of a linear equation with just 2 points, because you can find a line with just 2 points. We usually find 3 points just to make sure we are doing everything right, just to check and make sure that you found the right graph. Okay, so we have 3 points. Now we can graph them. We have the first point, 0 and 3. Second point is going to be 4 and 6. Yes. And the third point, negative 4 and 0. So we have 3 points. Let's find the points here on the graph. 0 is here, and 3, you're going to move 3 up. This is going to be 0 and 3. The other one, 4 and x equals 4, y equals 6. So on the x-axis, we move 1, 2, 3, 4, and then y equals 6. 1, 2, 3, 4, 5, 6. Then it's going to be here. This is 4 and 6. And the last one, negative 4 and 0. So negative 4, 1, 2, 3, 4, negative 4. And y equals 0 means we don't move up or down, we just stay here with negative 4 and 0. Connect the points with a line. This is going to be the representation of your linear equation. Don't forget to represent the arrow. This arrow here means the line is goes all the way to infinity in one side, and on the other side is a line that extends all the way to infinity. Okay, let's move on and work on another example. Graph the linear equation 2x minus y equals negative 4. Just remember, to graph the linear equation, we find 3 ordered pairs by choosing a value for one of the variables. And then we solve for this one variable that we have chosen. Usually we just need 2 points to find a line, but the third point will act as a check. We plot the solution points, then draw the line containing the 3 points. So we're working on this 2x minus y equals 4. Let's make x equals, let's assume any value for x. At the beginning I like to use 0 as the first one always, because 0 usually simplifies lots of things. If I make x equals 0, then we will have 2 times 0 minus y equals negative 4, right? So this is going to be 0, y equals what? 4, right? Negative y equals negative 4, y equals 4. So this is 1 point. Now we can find another point by making x equals 1. Yeah, x equals 1. It's a good guess. Good one. We have 2 times 1 minus y equals negative 6. Negative 4. If y equals 1 and to find the solution for y, the first thing you have to do is to subtract 2 on both sides, and then we will have negative y equals negative 6, right? Negative y equals negative 6, y equals 6. You can also make, let's say, y equals a number, any number. Like you can make x equals something and find y, or you can make y equals something and find x. Let's make, let's say, y equals 0. Yeah, y equals 0. Let's make y equals 0. Then we will have 2x minus 0 equals negative 4. X, divide both sides by 2, x equals negative 2. Yeah, that's a good one. So we will have x equals 0, y equals 4, x equals 1, y equals 6, 0 and 4, 1 and 6, and finally we also have x equals negative 2, y equals 0. So negative 2 and 0. We have 3 points. Graph the points on the rectangular coordinate system. So we have here 0 and 4. 0 is here, 1, 2, 3, 4. This is 0 and 4. The other one, x equals 1, x equals 1, y equals 6. 1, 2, 3, 4, 5, 6. This is 1 and 6, right? And x equals negative 2, 1, 2, and y equals 0. The point is right here. Negative 2 and 0. Connect the dots with a line. Don't forget the arrows. And this is the representation of your linear equation. Helpful hints. When graphing a linear equation into variables, if it is solved for y, it may be easier to find ordered pair solutions by choosing x values. If it's solved for x, it might be easier to find ordered pairs solutions by choosing y values. And if a graph crosses the x-axis, let's say here, at the order pair x equals 2, y equals 0, and the y-axis at, let's say, x equals 0, y equals negative 8, then those order pairs, they have special names. The first one is the x-intercept, and the second one is the y-intercept. Those are the points where they intersect the x-axis and the y-axis. Notice that for the x-intercept, the y value is 0, and for the y-intercept, the x value is 0. This is always going to be like that. Sometimes in mathematics, you may see just the number negative 8, yes, or the number 2. Sometimes you just say the x-intercept is 2, the y-intercept is negative 8. We don't say the ordered pair is. It's something that you may find in some books, in some references. Conclusion here from what we have seen, you have learned. To find the x-intercept, you let y let y equal 0 and find x. Okay, and to find the y-intercept, you let x equal 0 and find y. This is the conclusion. This is what we will apply a lot on exercises, on examples, when talking about x-intercept and y-intercept. Example, we have here graph 2x equals y by finding and plotting its intercepts. Wow, this is an interesting one. Check this out. Let's go back here. Let's go back. Let y equal 0 find x, right? And let x equal 0 find y. Let's try this. Let y equal 0. If you make y equal 0, you're gonna have 2x equals 0. That means x equals 0. And if you let x equals 0, then find y, and 2 times 0 equals y. That means y equals 0. What we're gonna see here in this particular example is that the y-intercept and the x-intercept, they are on the same point. They are both on the origin. So another helpful hint about that. Notice that anytime the x equals 0, y equals 0 is a point of a graph, then it is an x-intercept and y-intercept at the same time, on the same point. Why? It is the only point that lies on both axes. So the graph, if the graph crosses and passes and have this point, that means it is going to be both x-intercept and y-intercept in one point. And we were working on the 2x. 2x equals y, right? We know that 0 and 0 is going to be a point, right? This we have seen. This is going to be the y-intercept and the x-intercept. We can guess other numbers here. Let's say if x equals 1, y equals 2 times 1, 2. If x equals 2, y equals 4. Right? So we have 3 points. X equals 1, y equals 2. So this is 0 and 0 is 1 point. This is 1 and 2, another point. And 2 and 4, here, another point. Connect the dots and you will find the graph. You will find the representation of this linear equation. Okay? And I'm going to repeat the same thing just to make sure you understand. The point 0, x equals 0, y equals 0 is the intersection with the graph and the x-axis, and with the same graph and the y-axis, it is both y-intercept and x-intercept. Objective number 4, graphing nonlinear equations. And eventually you're going to need to graph nonlinear equations. And if 3 points are enough to graph a linear equation, even 2 points are enough. The third point is to check. To graph nonlinear equations, you're going to need more points. You need several points to be able to find an approximation for the shape of the nonlinear equations. One example is y equals x squared. These have a special name. This is the parabola. The name of this graph is a parabola. And we need to find several points here, several order pairs to be able to graph, to draw a nice and a good approximation of the graph. So let's guess a few points here. Let's say x equals -2. -2 squared is going to be 4. Let's say x equals -1. -1 squared is 1. Now x equals 0. Y equals 0. X equals 1. Y equals 1. X equals 2. Y equals 4. So we have a few points here, and I think we're going to be able to graph now. So the first one, -2 and 4. -2 and 4. 3, 4 here. Another one, -1 and 1. -1 and 1 is here. Another point, 0 and 0, right here in the origin. And another point, 1 and 1. 1 and 1, right? So it's going to be here. 1 and 1. And another point, 2, 1, 2, and 4. 1, 2, 3, 4, right here. Clean this up a little bit so to look only at the points that we just found. We have all the points here, and to find the graph, connect to the dots, connect the points, and the parabola is it looks like that. It looks like a U. Kind of looks like a U. This is the parabola. Now moving to another nonlinear equation, and this is the absolute value equation. Check this out. Let's find a few points here. Again, guess some values for x. -2. If x equals -2, y equals 2. If x equals -1, y equals 1. X equals 0, y equals 0, x equals 1, y equals 1, x equals 2, y equals 2. The absolute value function is an interesting one. Let's find the points here. -2 and 2, -1 and 1, 0 and 0, 1 and 1, 2 and 2. What's interesting about this absolute value function is that the shape of the graph will look like this. See? It looks like a V. Oops. It looks like a V letter. It's a V shape. Okay? And this is how we find the graph of the absolute value equation. Now let's graph the equation of the square root function. Y equals the square root of x. Assume some values for x. Let's say x equals 0, and then square root of 0 equals 0, right? X equals 1, square root of 1 equals 1. Let's find another number that have a good square root, a known square root. So 4, square root of 4 is 2, and another number 9, because square root of 9 equals 3. Now we have a few ordered pairs. We can graph here on the rectangular coordinate system. 0, 0, 1 and 1. 4 and 2, 1, 2, 3, 4, and 2 is here, and 9 and we have to stretch. Let's stretch the 5, 6, 7, 8, 9, and 9 and 3. We have a few points. We can draw the graph now. What's interesting about the square root graph of the equation y equals square root of x is that it looks like the parabola, see, laying down, but just half the parabola, not the whole parabola, half the parabola, because you don't have the square root of negative numbers. So one of the halves of the parabola is missing, is laying down but is missing, because you don't have in the real a solution in the real numbers for the square root of negative numbers. We cannot use any negative numbers on the x-axis. Okay, that's it. We conclude now the section 3.1. That's the end of section 3.1. Did you find the answer for our puzzle, the math puzzle? So the hint is going to be here on the name of the guy, the owner of the house. It's this Mr. Pascal. This is the name of a very famous mathematician, that he developed, or he thought about this kind of arrangement for the numbers. This is called the Pascal's triangle, and this is built by adding the numbers. You start with number 1, and then at the bottom you're going to have 1 and 1, and you add 1 and 1, you're going to have 2, and you're going to add 1 and 2, you're going to have 3, and on. 3 and 3, 6. See, the number of the bottom is the addition of both numbers on the top. Let's say here 5 and 10, 5 plus 10 is equals 15, and 15 and 6 is 21. To find the number that's missing, we will add 35 with 35, and then we're gonna find the missing number. 35 plus 35 equals, and I don't know if you can see, but clear, 70. 35 plus 35, the number that's missing is going to be 70. This is the answer to our math puzzle. Thank you for watching, and as usual, we meet again on the next section.